Hi everyone, welcome back. In the previous video I talked about the exact trig values and where they came from and what they are. Really, if you want to, you can go home and memorise all 9, but I don't like memorising 9 things when I don't have to. So instead of memorising a 9, instead I can just draw up 2 triangles. So we've got this triangle, we've got a right angle triangle, and if that's 45 degrees, it means the other angle also has to be 45 degrees. So that's an isosceles triangles, that means that equals that. So I want it to be the smallest and simplest numbers I can, so I put a 1 there and a 1 there. And using Pythagoras' theorem, it's in the previous video, that turns out to be root 2. So there's one of my triangles. The other triangle I can split that into an isosceles, equilateral triangle is a 60 and a 60. There's a 30 and a 30 because I split the triangle in half. What I've got here then, I want the simplest numbers I can again, so if I put 1 here for this side and 1 for that side, because they're now equal, then that becomes all the way across a 2, a 2 and a 2. Then by Pythagoras I've got to figure out what this other number here is here. Personally, I normally draw the triangle this way. I put the 30 there, and I put the 60 there, and I do actually, rather than doing that fully, my brain has memorised, or I memorised a long time ago, that sine 30 was a half. So you can think that way and work out what this one is. And so you can go through and figure out that that's root 3, or you can just memorise that's 1 and 2. So the 1 is the opposite, the 2 is the hypotenuse. So if I go to the triangle over here, there's the adjacent because it's next to it, there's the hypotenuse, so the hypotenuse gets the 2. That's the adjacent because it's next to the 30. So sine 30 being 1 and 2, so that's a 1. And by Pythagoras, if you want to go, what's the previous video? That's root 3. One shortcut for Pythagoras is 2 times 2 is 4. 1 times 1, I actually do it this way. 2 2s are 4. 1 times 1 is 1. Nice handy thing for Pythagoras theorem. And then I'm getting a shorter side, so I can't go 1 plus 4. Because that would be getting longer. I'm not wanting to get a longer side, I'm wanting to get a shorter side. So this would be 4 take 1 is 3. And if you have a look at the squares out here, that's 1 times 1. The 4 is 2 times 2. And the 3 is root 3 by root 3. So we've got to end up with a root 3 there. So if I get rid of those, or I could leave them there. I'll get rid of those. Now, someone has come up to me and said, my child has been asked to solve questions like these. I don't know what school they go to, I don't know what the original questions are, but it had things like this. If sine 30 equals 1 on x, solve it. Another one, if tan 60 equals 2 on x, solve it for x. There's a lot of maths in there. Not that hard, but there's a lot of maths in there. I've actually memorised, normally I expect my students to hold up a flashcard and go sine 30 is a half, see them around the school and go what's sine 30 and they'll say a half, until it sinks into their brain. So I could go back to the triangle though and go there it is, opposite, sine is opposite on hypotenuse, if we're starting at 30, different if we're starting at 60. Starting at 30 is the opposite on the hypotenuse, in other words we're not using the adjacent. So here we go, sine 30 is a half. And I've got this equation which is a half equals 1 on x. And there's about 3 ways I could teach it, but I'm going to show you what I prefer probably most of the time. It's called cross multiply. Someone else watching this can say, oh, I could just turn them upside down. And it is good to turn them upside down. There's another method. First I'll do cross multiply. It means you start here, you go to the other number here, or letter in this case, and you multiply those two. That's 1x. Only works when there's one fraction and one fraction. If this said plus 5, it won't work because it's no longer one fraction. You could talk about 5 as a fraction of 5 over 1. Only works if it's a fraction on the left and a fraction on the right, cross multiply. And then I can do the other pair. So I can go that pair there, multiply them, 2 times 1 is 2. And then you can just say that the answer is x equals 2. So the question in itself is not that hard, but it's the fact that a lot of people don't understand the exact trig values. I usually just do a cross there. So the 1 goes with the x, which is 1x. The 1 goes with the 2, which is a 2. Actually, it doesn't matter which order. You can go 2 by 1 and x by 1. You can do just about anything you like. Let's go to this one here. 10, 60. Now I'm going to go to the 60. So that's no longer the opposite, that becomes the next to the 60 is called the adjacent. Across on the 60 is called the opposite. So how do we get the 10 to 60? Most people are okay, but I know some people struggle with it and have to think this every single time. 10 is opposite on adjacent. So I'm going to get a fraction for 10 starting at 60. So I'm going to say what is opposite? The root 3 is opposite. 1 is adjacent. So I've got root 3 on 1 equals 2 on x. Now if you look at the previous method, just do it this way. There's the root 3 by x. So a lot of people come unstuck with their equations. And that pair is 1 times 2 is 2. So we're nearly there. You've got a root 3 x. Now we want the x to be by itself. We want the equation to say, here I am, I'm the answer. So that's how it says, here I am, I'm the answer. You just want it to say x. If it says something else, it's not saying I am the answer. So how do you get rid of the root 3? I'm going to move that out of the way. In between the root 3 and the x is a multiplication. So how do I get rid of a multiplication? The opposite of multiplication is division. So if I divide that side by root 3, I've got to balance it up. It's like a set of scales that suddenly you make one side less and the other goes up, and you've got to sort it out and get it to balance back up again. So if I divide this side by root 3, I divide that side by root 3. Anything divided by itself is 1, so that's actually 1x, and the answer to it is 2 on root 3. That's what we call exact values. If you put in your calculator, you'll get a decimal, and instead of being exact value, it's then an approximate value, because the decimals for root 3 will go on forever without any pattern to them. So that's an exact answer. So what's the trap? If the question said, if your answer to 2 or 3 decimal places, you put it in your calculator, write it down. Of course, we don't have to have the 1 there, because it's talking about the 1x. Now all I can do now is more complications of what to do with these equations. I want to go back to this for a second. Cross multiply any top by the other bottom, and then the other top by the other bottom. And you write them down. So it's numerator by denominator, and then it's the other numerator by the other denominator. And that gives you a solution to those questions. Hope it helps. Thank you.